This is problem number 3 from section 2.3. In this problem, they want us to solve the inequality symbolically, express the solution set in interval notation. Now, we have a compound inequality here because we have two inequality signs here. So we have more than one inequality sign. They call that a compound inequality. It's not really going to change how we solve the problem. We have a denominator that's in the middle. The only difference here is we're going to solve so that the middle has x in the middle, and we're going to be between two other numbers. So because of the fraction, again, we're going to multiply by the denominator, which is 5. But we have to do it to all three parts of the compound inequality. So we're going to say 5 times negative 5 is less than or equal to 5 times 1 minus 8x over 5, which is less than 5 times 20. So you can see I just multiplied each part of my compound inequality by 5. This creates negative 25, less than or equal to the 5, because it's really 5 over 1. The 5's actually cancel, leaving you with just with 1 times 1 minus 8x, which is just the top portion, the top two terms, 1 times that. So less than 5 times 20, which is 100. Now we can go ahead and solve this from here. Subtract 1 on each side. So we're going to go minus 1 on the left and the right. That's negative 26, less than or equal to negative 8x, less than 99. The last step then, we're going to divide by negative 8. Now we have to watch ourselves with the inequality signs because we're dividing by a negative. Anytime you divide or multiply by negative, that flips the inequality signs. So negative 26 over negative 8 reduces to 13 over 4. And we flip the inequality sign, which is greater than or equal to x. We flip this inequality sign, so greater than negative 99 over negative 8. I think it's just going to leave us negative 99 over 8. We can't reduce that. So, again, I like to rewrite these. So I'm going to say negative 99, because it's the smallest number, over 8. I make sure the less than sign is pointed toward it, just like it is here. X, I know the less than or equal to sign is pointed toward x, so I say less than or equal to 13 over 4. It says write it in interval notation. Well, that means that negative 99 over 8 is the smallest number, but we can't equal it because it says less than, or it says x has to be greater than that. So we can't equal that. We can be just above it. This one we can equal 13 over 4. So we're going to say 13 over 4, but because we can equal it, that's a bracket saying, hey, 13 over 4 is a solution, but anything less than 13 over 4 all the way down to negative 99 over 8 also works. So here's our solution set.